Hello and welcome to an Edexcel iGCSE Computer Science past paper question. This is paper 1, Principles of Computer Science from May 2024. This is a theory paper. Total marks out of 80. So we'll jump in and get started. But before we do, as always, please like this video, share it with those that need it, and don't forget to subscribe. Thank you. Question 1. There are different ways to connect computers in a network. Give two differences between a WAN and a LAN. A WAN, wide area network, covers a wide area. A LAN, local area network, covers a smaller area. For example, college campus. WANs connect multiple LANs. A LAN is a small network. B. Give one security risk of connecting computers in a network. There is the risk of the spread of viruses. So viruses could easily be spread in a network. C. Figure 1 shows a network topology. State the name of this network topology. We can see all the computers connected together, so it is therefore a mesh. Now you get the mark for saying it's a mesh, but we can see that this computer is not connected to this computer here, so it is actually partially connected. 2. State one drawback of using this topology. The cost of installation will be quite high for this because there's a lot of cabling involved. 3. A fault-tolerant network delivers a reliable service. Explain one reason why this topology is fault-tolerant. So if one computer goes down in the mesh network, the rest of the network isn't affected because data can still travel. Each device is connected to the others, so data packets can still easily travel throughout the network, despite a computer not functioning or a connection going down. D. Identify which of the 4-layer TCP/IP model is responsible for transferring packets across a network. It is the data link layer. The other layers are not involved with the transfer of packets. E. Here is the address for a web page. State the protocol being used. It is the secure protocol. And 2, give the name of the document being retrieved. It is the web page specification.html. And that completes question 1 for 10 marks. 2. Computer systems use hardware and software. A. Two types of software are application software and system software. State the purpose of application software. Application software allows the user to do something, so to perform a task. 2. One function of an operating system is to provide a user interface. State 3 other functions of an operating system. One of them is memory management, so scheduling of tasks. Another one is user management, so allowing the operating system to allow different users with different levels of access and corresponding usernames and passwords. Another is file management, when you go to save files, updating the file allocation table and assigning the data specific parts, sectors in the hard drive. B. Computers use different types of storage. Explain one reason why computers need both RAM and ROM. RAM and ROM are two different things. RAM is for the storage of frequently used instructions by the CPU, data instructions by the CPU. ROM, read-only memory, is used for storing the BIOS information that the computer needs on startup, so information about the hardware. So RAM is used as part of the fetch, decode, execute cycle to store frequently used data instructions accessed by the CPU. ROM, read-only memory, is used to store BIOS, basic input-output system information about the computer, which is accessed during a power-on self-test at the starting up of the device. 2. Explain how data is read from a magnetic hard drive. Now this is 3 marks, and needs to be quite a bit that you write for this. Data is stored on platters using magnetic polarity, north and south to represent ones and zeros. The platters spin, so what you have is a read-write head. The platters are spinning at approximately 7,200 RPM. Now, the read-write head is reading the surface of the disk and reading the polarity values, ones and zeros, from the surface of the disk. Now, I think that's probably as much as you need to write for 3 marks there, but there should be more than just a couple of points there. So it should mention that data is stored magnetically, magnetic polarity, north and south to represent ones and zeros. You have a spinning disk. On those disks is the polarity values, and the read-write head is reading those polarity values to represent ones and zeros, which is how data is stored on the hard drive. C. Computers perform the fetch, decode, execute cycle. Complete the table by writing the numbers 1 to 4 in the sequence number column to put each stage in the correct order. So we have our stage and our sequence number. The instruction is placed onto the data bus. The arithmetic and logic unit performs a calculation. The address of the next instruction is placed on the address bus. The instruction is decoded by the control unit. So you need to remember for this question, fetch. So fetch an instruction, decode, and then execute. So execute is performing a calculation, so that won't come till the very end. Instruction is placed onto the data bus. That is part of the fetch. The address of the next instruction is placed onto the address bus. The instruction is decoded by the control unit. So the first thing is the address of the next instruction is placed onto the address bus. Then the instruction is placed onto the data bus. So the address bus takes the address to the memory location in RAM and comes back on the data bus. The actual data and instruction comes back on the data bus. So that's the fetch part. So that's the fetch part covered. The instruction is decoded by the control unit. Finally, the arithmetic and logic unit, ALU, performs the calculation, and that is the execute part. So it's fetch, decode, execute. And that is the correct sequence. D. Identify which one of these buses is unidirectional. So unidirectional is one way. Is it the address bus, control bus, system bus, or data bus? The answer is A, the address bus. It's the address bus because it's the address going to the memory location, so it's one way. Just going to the memory location where the data instruction is stored that the CPU wants to work on. And that completes question 2 for a total of 14 marks. Question 3. Computers use binary to represent and store data. 2 images are stored. Image 1 has a color depth of 8 bits. Image 2 has a color depth of 16 bits. Take the number of colors that can be represented in image 1. 8 bits gives us a total of 256 colors. That's 2 to the power of 8. 2 times 2 times 2, 8 times, which gives us 256 colors. 16 bits is 65,536 colors. So it's 256 colors with 8 bits. Image 2 is, I need to keep this bit on the screen to be able to answer this question. Image 2 is 1920 pixels wide by 1080 pixels high. Construct an expression to show how the file size of the image in megabytes. That's megabytes. That's 1024, not 1000. You do not need to do the calculation, so we'll go and put that expression together now. So the width and the height are multiplied together, and that's the first mark now. Now there's 16 bits, so all that needs to be multiplied by 16, then the whole lot divided by 8, and then all of that gives me 8 bits in a byte, then all of that divided by 1024 squared. Now it must be 1024, not 1000, otherwise the answer will be wrong and you won't get the marks for that. So 1024 times 1024, that gives us that in megabytes. If it's just 1024, it's kilobytes. So to get to megabytes, I need 1024 squared. 3. 1 pixel in image 1 is represented by the unsigned binary integer 11001010. Identify the denary equivalent. Unsigned means it's not a negative number. So D is out. If it was signed, then that would represent a negative number. The correct answer is C, 202. It's more than 54 because we've got 128 in the most significant bit. So 128 plus 64 is already 192, so it's bigger than 191. So the correct answer is 202. B, a register holds the value 11000001 as an 8-bit value in 2's complement. Convert the 2's complement binary I've just read out to denary. So the thing to remember with this is flip the bits. So zeros become ones, ones become zeros. And you can see I've done that there. So all the ones became 0 and the zeros became 1. Then the final step, add 1. So our final answer, which needs to be converted into denary, so that's the extra 1 there, so that is 63, but it's actually negative 63 because it's a negative number, so the answer is minus 63. So remember, flip the bits, add 1. 2. Give the result of applying an arithmetic shift left by 1 to the binary pattern there. So when we shift the digits left, then the bit pattern moves to the left. But because this is an arithmetic shift, the 1 should be preserved. But luckily, if you weren't sure of that in the exam, if you weren't sure how to answer that, you've already got that extra 1 there, so that isn't going to change that very much. But that most significant bit in an arithmetic shift should be preserved. So we start with the 1, 0, 0. So I'm keeping these 5 zeros here, then the 1, and then the 0. So that is the left shift by 1 of that bit pattern. So remember, an arithmetic shift, the most significant bit is preserved because it's representing a negative number. In a logical shift, the most significant bit is not preserved. 3, the value here, 11111111, is added to the value 11000001 stored in the register. An error occurs. Explain this error. Now you don't actually need to do the addition. The error that's happening, which should be obvious if you look at the most significant bit, is you're going to add a 1 and a 1. You're going to end up with a carry bit. So what you've got here is something called an overflow. You need to describe it as an overflow because you've gone into the 9th bit, which doesn't exist. You've only got 2 8-bit numbers. So you needed the 9th bit. That doesn't exist, so that's the problem here. C. The ASCII code for the character 1 is 0110001. Give the ASCII code for the character 5. So the answer is 0110101 because just simply count it. So 5 is 0101. So that's the answer. 2. Give 2 benefits of using ASCII to encode characters. So the first benefit is it only uses 7 bits. So smaller storage requirements, so up to 128. So 128 characters. So it only uses 7 bits. Remember, ASCII is 7 bits. Extended ASCII is 8. Second one is it's a universal standard way of representing characters. Now that completes question 3 for a total of 13 marks. 4. Peter and Marie are employees at a research facility. A. Peter is creating a predator-prey population simulation of rabbits and foxes. He creates rules to simulate the movement and feeding patterns for each animal over time. One benefit of predator-prey simulation is that it's simpler than monitoring real-life animal populations. Explain other benefits of using the simulation. So it's obviously going to be a lot safer than working with real-life animals, real-life wild animals, which are unpredictable. There's something you could focus on here. You could ask what if questions. So what if certain scenarios happen? How would the population cope with that? So I've written it can be used to predict future scenarios and ask what if questions that could be useful. B. Identify the computational model in which several computer systems work together to achieve a goal. It is the multi-agent model. It's not parallel or sequential. So sequential is one thing after another. It's not parallel because that's thinking of the CPU, so a multi-core CPU, so that's not applicable here. And the input process output model is something slightly different to what's asked in this question. C. Employees at the research facility use a biometric identifier to log in to the network. Describe one other security measure that could be used to ensure that employee is who they claim to be. So I've written 2-factor identification could be used. So both password and a unique code generated on an app, for example, which is usually what happens these days. You have the app. So to get onto Edexcel Online, you need to put in your credentials, your username and your password, but you also need to verify that on the Edexcel app. So that could be used to ensure that someone is who they claim to be. D. Is a researcher in nanotechnology. State what is meant by the term of nanotechnology. Nanotechnology is a manipulation of matter at an atomic level, and one application of nanotechnology is the miniaturization of technology. So that's all you really need to write for 1 mark, but you can think of the applications and use cases of that, which are tremendous, really. E. Marie has a mobile phone. The address of the device is listed here. Describe the relationship between the structure of this address and the total number of bits required to store it. So if we look at this, we've got colons between these 4 digits. So this could potentially be a MAC address, but it's not. It could be an IP address. So we count the number of, look at the numbers between the colons. E. Marie has a mobile phone. The address of the device is listed here. Describe the relationship between the structure of this address and the total number of bits required to store it. Now, this is an IPv6 address. It is way bigger than an IPv4 address, which is 4 octets. This is much bigger. So this address uses a total of 128 bits. Each block needs 16 bits. You see 4 digits there, hexadecimal. So each block needs 16 bits. And 16 times 8 is 128. So just an explanation of what's happening there. F. The research facility is considering introducing cameras and facial recognition software to monitor the work and movement of people on and around its site. Discuss the privacy issues that need to be considered when deciding whether or not to install this new system. So cameras that record footage, CCTV, facial recognition, that is data. So that comes under very strict legislation because it is private data. So this data is highly sensitive and needs to be treated as such. People have the right to know that their facial features are being recorded and stored. The system needs to be carefully programmed and obviously the data carefully monitored and the data it's fed carefully filtered to avoid some kind of algorithmic bias that would affect its ability to be neutral and could lead to potentially difficult situations. The data is highly sensitive and needs to be held securely to avoid it being leaked to persons with criminal intent. This is based on a real-world scenario. In King's Cross in London in around 2020, facial recognition software was introduced, but it was very quickly removed and taken away because there was a lot of backlash from people who used that area, worked in that area, that didn't want their data being held in such a way. Now, some people would argue if you've got nothing to hide, you've got nothing to worry about, but it's not always about that. It's about what's happening to this data. So what I would also add to this is companies need to be very clear about what they're using this data for and what their intent is to store this data. What's going to happen with that data? Are they going to hold it securely? And what are they going to use it for? And not go beyond the boundaries of what they state. But this is a highly controversial issue and has proved to be quite problematic when it has been introduced, particularly in London, in King's Cross, in the earlier part of this decade, around 2020. So there's plenty you can pull out for this. It's quite a nice question. There's plenty you can write for that too. As long as you've got at least 3 major points there with because and an explanation, so point, evidence, explain, you should be able to get 6 marks, achieve 6 marks in that question. And that completes question 4 for a total of 16 marks. Question 5. A team is developing a computer game. Complete the table by adding a tick to show the characteristics of programming language translators. You may select more than one translator per characteristic. So we've got our characteristic on the left hand side and the translator, assembler, interpreter or compiler. So the first characteristic does not have to be present in memory to execute the translated code. The most obvious one to go for there is compiler, but you can also have as well, you also need to put in there assembler. You're getting marked by the columns that you get correct. Second one, translates high-level language source code, so that is interpreter and compiler. Executes high-level code until either the program is finished or a syntax error is encountered. So high-level rules out assembler, So until the program is finished or syntax error is encountered. So that is interpreter, because it will run until it encounters a syntax error, then it will stop running. Whereas a compiler compiles a whole program and then generates your list of errors after it's done that. Translates low-level language source code into machine code. That is the assembler. B. Luca is testing the computer game. The computer that is using is an older model with a processor that runs at a low clock speed. Explain one drawback of testing the game using this computer. The game will basically not run as well as it should do. So low clock speed will mean that the processor will not be able to process as many instructions per second as a faster processor. Therefore, the game will appear slow and will lag. Won't be a representative gameplay. C. Annie uses utility software. Complete the table by adding the type of utility software she should use to solve each issue. Her word processor cannot read all of the file because it's corrupt. File repair would be useful for that one. She has a JPEG image and needs to send it to a publisher who can only read PNG image files. She needs a file type converter. There's been a flood and files on the server have been damaged, but Anna needs to access her data. She should hopefully have a backup, otherwise it may be that she cannot access her data. Her hard drive is running very slowly when she tries to access a file. The first thing that came to my mind was antivirus, but before she tries that, it may be that the hard drive needs defragmenting. If it's a solid state drive, then that wouldn't be the case. It would likely to be a virus, but if it's a magnetic drive, it may be fragmented and she needs to run some defragmentation software to be able to access the file. D. Tarek is writing an instruction manual for the computer game. He decides to use utility software to compress the instruction manual before emailing it to a proofreader for checking. State and justify the most appropriate compression method. Now this is either lossy or lossless. It obviously needs to be lossless because if it's lossy, then he's going to lose some of the text. So if he uses lossy compression method, then some of the text will be lost and the manual will be damaged. E. Members of the team developing the game are either coders or designers. Coders, C, write the application code. So you need to start by putting in the letters as we get them. We'll start with the C. That's our coders. Now I'm just going to place them here with some space in between. I obviously can move them, but if you're writing this in an exam, handwritten exam, leave some space between the letters. Designers, D, design the graphics for the game and write the instruction manuals. Team members have only one role only. Construct a logic statement using and or not with the letters C and D to show the conditions for being a team member. So always place the start as C or D, but that's not really enough. That's only one mark. So there can be a coder or a designer, but we haven't dealt with the condition, the third point there. Team members have one role only. So they could be C or D, but they cannot be C and D. They cannot be both. So to be able to make that work, we need to put a not in there. So they can be C or D, but not C and D. And that covers that statement. So they can be C or D, but they cannot be both C and D, because with an or they could be both. So to be able to cover that base where they cannot be both, we may use an exclusive or, but as we haven't got that, we've been told not to use that, and that's not in the specification. You do not C and D. So they cannot be both. It could be one or the other, but they cannot be both. And that completes question 5 for a total of 15 marks. Question 6. Pseudocode and flowcharts are used to create algorithms. A. The number of minutes a train is early or late are recorded each day of the week. A value of 0 is recorded if the train is on time. Negative is recorded if the train is early. Positive if the train is late. The algorithm figure 2 has been created to calculate and output the total number of trains that were early, on time or late. So you've got arrival to -2, 1, 5, 0, negative 3, 4, 1. So that's obviously the arrival times in the array on line 2. So arrival has been set there, the comma separated values in that array, set early to 0, late to 0, indexed to 0. So what this algorithm is going to do is record the number of early trains. So the early trains are negative, so we can see we start with an early train, a positive if the train is late, and then 0 if the train is on time. So lines 4, 5 and 6, we set those values to 0 initially, while not index greater than length of arrival do, and then if arrival index greater than or equal to 0, then set late to arrival index. So a positive value is recorded, so if it's greater than or equal to 0, then it's set as late. Now you may already be able to see a problem with that. Then if arrival index is less than 0, then increment early by 1, and index plus 1, so that increments the index. So look at the next element in the array. So then to lines 23 through to 24 is just to display the number of late, on times and early trains. So identify the iteration construct used in figure 2. So iteration construct can be seen on line 8. Is it a post-condition loop, a count-controlled loop, array loop, or precondition loop? So the wording of this is slightly unusual. We haven't seen before in other questions. So the key to this is to eliminate possible options. So it's not an array loop. There's no such thing as an array loop. It's not a count-controlled loop because a while loop isn't count-controlled. A while loop is condition-controlled. So is it post-condition or precondition? Post-condition means that it looks at, so it will be a while loop, but the condition will be at the end of the loop. Whereas precondition, the condition will be before the loop starts. So on line 8, we can see the loop, we can see the condition, so it is in fact a preconditioned loop. And just to clarify that, a post-conditioned loop would look like a repeat, which we don't often see. Just as a point of interest, is worth noting the pseudocode notation here. So what I always say to my students is definitely use this. So if you weren't sure there, you can look at this and this will give you some clue. So you get this with every exam, and this is a pseudocode notation that comes with the exam, the command set. So it's definitely worth having a look at that and taking the time. If you're not sure, rather than just guessing, go and have a look at that. That may be able to help you. There are 4 errors in the pseudocode. Write the correct code for lines 0, 8, 10, 11, 23. So let's go and have a look at line 0, 8. While not index greater than length of arrival do. So while the index isn't greater than the length of arrival do, the length of arrival is 7. So if you think about that logically, while not index greater than length of arrival do. Now this loop will mean that it keeps looping long after it's reached the final element in the array, because it goes from 0 through to 6. So this will go to look at element 7. It will be out of range. So it needs to be the corrective version greater than or equal to length of arrival. Now, because of logistics, I'm just going to write on here, or you could length of arrival -1. But I have talked about that in previous videos. It's a common question that. I'm just going to write on here just to save time. So line 10. What's the issue with line 10? If arrival index greater than or equal to 0, then it's late. Now, if it's 0, then the train is on time. So that needs to be greater than 0 rather than greater than or equal to 0. So we'll just put a line through that, because that isn't right. And the correct version should be greater than 0, the corrected version, or greater than or equal to 1. Line 11, let's go and have a look at line 11. Set late to arrival index. Now all that's going to do is every time that's going to set the late to whatever that is, but we want to count it. So set late equals late plus 1. We want to increment that like the early. So we don't want this here. So we can put a line through that like that. And I want it to be late equals late plus 1. Otherwise that's not going to work. That's not going to increment my number of lates. Line 23. What's the problem with line 23? Send trains on time, colon, and ampersand. So can late and early to display. So the number of trains that are on time is calculated from all the trains, subtract from that the number of earlies and late. So trains on time is the total number of trains. So just move this up here, just so you could see that there. This is replacing this here. So just put a line through that there, and then we will obviously want the to display. But length of arrival, subtract late, all the late and early trains to give me the number of times that the trains were on time, exactly on time. And that is exactly 1, because we can see 0 there where the train was on time. So that should give us 0. C, give one reason for the variable index being incremented in line 18. It's incremented so it can access each element in that array. And then we've got FizzBuzz here. A flowchart in the game FizzBuzz, a user enters a number. These conditions apply. If the number is divisible by 3, the program displays fizz. If the number is divisible by 5, the program displays buzz. If the number is divisible by 3 and 5, the program displays FizzBuzz. If the number is not divisible by the 3 or 5, the program displays the number entered. So hint, if one number is divisible by another, there is no remainder. So need to be using modulo. So here are the components needed for the flowchart. Start everything with a terminator. Now just for ease of use, I'm using PowerPoint just to create this. I'm going to go through the steps of creating this flowchart. So I'm just copying and pasting some of the symbols there. There will be a line drawing these two together. So start, I'm going to get the number. Now go back to the question. So I've got my number now. If the number is divisible by 3, the program displays fizz. So let's go and do that now. So my left here is going off to the right. But if we look at this question, there's something we need to do. So the third bullet point, if the number is divisible by both 3 and 5, the program displays FizzBuzz. So if the number is divisible by 3, we need to check if it's divisible by 5 as well. So this is a yes then. So divisible by 5, yes. Okay. Is it divisible by 3? Sorry, yes. Is it divisible by 5? Then if that's a yes, then we can display FizzBuzz. So just to go through this then. So we'd have that arrows joining that there. Here we've got a question. So the no, we haven't dealt with yet. Okay, but this is a yes there. It's divisible by 3. Okay, great. Is it divisible by 5 as well? Yes. Then it's a FizzBuzz. If no, it's only divisible by 3. It's a fizz. So rather than just saying go straight away to say it's a fizz, you need to also check if it's divisible by 5. You're given 2 of these for a reason. So now let's deal with this. It's not divisible by 3. Okay, let's go through it. This is the final drawing. So start, get number. Okay, is the number divisible by 3? Yes, it is. Okay, great. Is the number divisible by 5? Yes, it's a FizzBuzz. If no, it's divisible by 3 but not by 5, it's a fizz. Okay, the no, then check again. We're given 2 of these, remember. Is the number divisible by 5? Yes. Then it's just a buzz. If no to that, then we just display the number and stop. And that completes the flowchart. And that completes question 6 for a total of 12 marks and the whole paper for a total of 80 marks. Thank you very much for watching. I hope this has been useful. If it has, please like the video, Please share it with other people and please consider subscribing. I'd be really grateful, and I'll see you in the next video. Thank you very much.